before we switch over to the kind of vendor panel, I want to ask you kind of a couple questions. So how many people watched the Super Bowl yesterday? How many people liked the result? All right, Denver. Hey, all right. As I was watching the Denver game, I was thinking about what would be your commercial for smart manufacturing. You know, everyone looks at commercials, the 30-second spot. What would be your 30-second spot to talk about smart manufacturing? Would it be a, I'm going to guess at this, 70-year-old foundry in Pennsylvania, in Scranton, with dirt on the walls from the soot from the furnace, with floors made out of brick? Would that be what you'd say your advertisement for smart manufacturing is? Would it be a steam methane reformer that's the size of a frickin' apartment building and has an open atmosphere with 300 tubes in it that luckily the plant doesn't have any walls in it because it'd probably blow up if it did? Or would it be robotics and clean and high-speed motion and things just clicking along, and you'd look at that and say, now that's smart? What we're talking about in smart manufacturing is trying to figure out how to meet people where they're at. And not to have these barriers that say, well, I'll tell you what, before you get smart, you got to spend 20 years getting an ecosystem of stuff put together. You've got to build on all this data repository. You got to do all this stuff before you can even start. What if your smart manufacturing ecosystem was, I just want to gather some information from people and then act on it? Or you could go the other side and say, yeah, I have 100 billion data points a day, and I want to find the needle in the haystack. So the challenge that we have on SMART is this concept of trying to meet people where they're at, meet plants where they're at, and not have to have additional infrastructure put in. And you see in these two pilots, which I find really interesting, I'm not sure what that 30-second commercial is going to look like at General Dynamics, but it isn't what you'd think it looked like. It's not this really slick, modern factory that, of course, it's smart. These are, in many cases, these are World War II assets that we need to figure out how to make smart without starting over. And so our challenge is trying to go across this entire paradigm. How many people want to know how we actually do this? Anyone know how? Because I can skip those slides if no one wants to know. Just two? I'm going to go through this pretty quickly. You can grab me afterwards if I bore you to death on this. I've got some slides to talk about how this is accomplished and the technical challenge and the details of actually making this happen. And we're doing this in an open source way, right? So what I'm going to show you up here is not proprietary to smart manufacturing. We're taking essentially off-the-shelf technology in an open source manner and trying to weave this together and create a wireframe of this in a differential way. So we talked about this earlier. The concept of meet people where they're at, that's this bottom part right here. Every factory has something. Whether it's run by people, it's run by PLCs, it's run by distributed control systems, it has historians, it has maintenance packages, it has sensors of some kind, plants have something. And we're saying on top of that something, and we're going to have our panelist of vendors come up here in a minute with Rockwell and Emerson and Savagent and OSI, talk about they're the something that people are putting in. How do you take a platform and put that platform on top of wherever somebody's at? And do the contextualization and then build in those applications that solve problems. So Jesus talked about this whole issue of, I have a furnace the size of an apartment building that has non-uniform temperature profile through it. The application that was added into this wireframe was a model, computational flow dynamics model using high-speed, high-clustered computing power that Praxair did not happen to have, right? So this issue of we've got companies that don't have the resources to solve the problems they want to solve, right? So they're renting the computer power. They used Tom's boy geniuses of the world to figure out the models that would apply to this. And at the end of the day, in the cloud, on this wireframe, and I'll show a picture of it next, on this wireframe, the information goes through the computational flow dynamics, and it comes back to Praxair. And what Jesus didn't tell you was those 90 valves that they adjust in clusters of 4 are not automated. And when you tour the factory, you can see it's a big hand wheel. That's smart manufacturing at work, right? The final element is telling some person, some operator, to go over to that cluster and turn the crank. So again, clear it in your head, Super Bowl commercial time. Is this about a solenoid, a servo motor, $1 million worth of valve clusters? It was about all of the knowledge being applied to this problem to tell an operator how far to turn the knob. That's what we were doing. So we were going through the cloud and then totally coming back. I'm just going to build this quickly. So the approach in our wireframe is, again, we're centered on on-demand composable solutions marketplace. That's the apps. That's kind of your app store. We have all these elements that we have to try to address with our platform of engaging with the workers to make sure they do it, having a secure platform, nearly zero startup, right? When you think about your phone, you just hit download and it does. Commercialization opportunities to be disruptive for people that are thought leaders and want to create small businesses, et cetera. Adaptive test beds so we can continue to grow our capabilities based on company A and company B and company C, and heavily exploiting data and modeling. And we needed to have a wireframe or a platform that enabled that. You saw this slide. I'm going to talk a little bit about the bottom half and then go into a couple architecture slides. A couple things that are different here than what you might see either on a show floor or in other product offerings. Workflow as a service. So how many people are deploying workflow in their production environment today? A handful? This would have built-in workflow. So you think about the concept of trying to take action and to try to drive results at the speed of business. Are you going to just alarm somebody, notify somebody, or are you going to take control of that action and ensure that that action is done? And that action could be spinning up another application. It could be communicating to another customer's set of infrastructure, right? So this concept of a workflow is what allows us to go across tiers. In my little intro speech, I talked about N tiers. I want to be able to daisy chain across tiers, and we're going to use workflow to make that happen. Contextualization is going to happen in data modeling, and then security is kind of a given that you don't even get to play until you have a secure environment. So it's nice to be able to have a test bed with General Dynamics because it's military driven. Okay, how many can read that? You probably can't read that in the back. Anybody have any questions? So here's the story. We started about 3 years ago, and we knew we wanted to use cloud technology to be able to do this. So the concept of meeting people where they're at, Jesus talked about in the old days, right, having to put up a new server every time you wanted to solve something, and then you get your IT people involved, and then so on and so on. We all know how that story goes, not to bash our IT friends, but could we do it quicker, cheaper, better with taking advantage of Internet of Things and kind of modern technology? And of course, the answer is sure. Of course, everyone's freaking out about security and on-premise, off-premise, and that's an ongoing discussion. I'm sure there's going to be many sessions this week, as there were as there was last year around security. But we picked an open platform for cloud providers. We picked OpenStack. So we didn't pick Microsoft Azure. We didn't pick Amazon. We didn't pick Google. We picked OpenStack. And OpenStack runs in many different companies. There are many different companies that offer OpenStack as a platform to provide your wireframe. And then ultimately what we did was start building out these wireframes, and I'll show what it looks like for General Dynamics, and I'll show what it looks like for Praxair. But you have these marketplace apps, and then you have this user-defined stuff. So there's this whole space of marketplace, and what would be a marketplace app? It would be some sort of connection. So we've got Emerson and Rockwell and OSI integrating their technologies into our smart manufacturing platform as an example, because we've got customers that have those products, and those products then need to be connected in so that we can act and do something with that. You'll see over on the far left-hand side that there are cloud services and supply services and connectivity. Here's how the Praxair system actually works. We have wired sensors, we have wireless sensors. We go into a Delta V DCS system. A Delta V DCS system goes into a plant historian. Basically, the point on here, you can see this dotted line here. Everything below this line is on-premise. It's on Praxair premises. Everything above the line is in the cloud on Smart Manufacturing Platform. So what's going on here is this concept of meet them where they're at. So where they're at, they already had all this stuff. Now, what Praxair had to invest of their own dollar was right over here. They spent $1 million in roughly, right, in putting these thermal imaging cameras into the apartment building, so that they could coverage how much? 90%? What percentage? 80%. So they cover 80% of the space inside the apartment building to actually get those heat maps that then the algorithms could work against. So they had to invest in they had to invest in that. And then all of this stuff that existed at Praxair was then connected to our wireframe of our smart manufacturing platform. And I think I have some screens that I'll talk a little bit about. So at Praxair, as an example, they wanted to use Tableau as a visualization tool. So we put Tableau into our wireframe. Energy Advisor, that's Emerson's technology. OSI Pi, Historian, we put all of this stuff in the cloud. And then our workflow engine to be able to acquire, calibrate, optimize, spitting it back, our furnace models that we talked about with ANSYS and MATLAB and optimizers. And all of this stuff in the top section was cloud-based. So you get a concept here of, the spirit of smart manufacturing, the spirit of making your plant smart is, in fact, meeting them where they're at. Where they were at was down below, connecting them to new capability up above. Like Jesus talked about, this wasn't a big deal from a Praxair infrastructure standpoint, because the only thing that's going across is right here. This little box here, this publish secure FTP service, was something Praxair already had. So this isn't the way we're going to necessarily do it long term. Again, this is a demonstration of capability. This will be done in a different manner longer term. General Dynamics, very, very similar. On-premise, all this stuff existed, except they didn't have the capability of taking their data and putting it into a concentrator or basically a historian so that the data could be brought together. And again, what we're bringing to the table with the platform in the cloud, again, they want to use Tableau, so on and so on, real similar in concept. Right? So what you'll see is that in both examples of the Praxair testbed and the General Dynamics testbed, one's a continuous process, one's a discrete process. But we go from plant sensors, real-time data, to the cloud, and then back to the folks in the plant, whether that be through information or ultimately. So today it's through information. Ultimately, it would be closing that loop. So this is the second year of the work. So they're starting off with information first, and then control second. So workflow as a service, data models, secure connections. This is the picture exploded out that was on Tom's slide that you couldn't really see. This concept of having multiple then cloud solutions. So as an example, let's assume for a second that General Dynamics and Praxair wanted to do business together. Say that General Dynamics and Praxair were companies that needed to integrate from a demand-driven supply chain. The concept of our platform is you got platform-to-platform connectivity, right? So this stuff is in the cloud. It can actually connect and bridge across. I need to have that in the food industry as I have end-tier capabilities. I have to have suppliers talk to customers, talk to converters like myself, and share those platforms and wireframes across each other. At the very end, right, you need to act on it. And this is just a little visualization. Some of this is done with Tableau, trying to build, and some of this is done with Emerson. The concept of heat maps, the concept of taking this information, the concept of this stuff is being crunched really quickly. How you get this stuff visualized, that's what's going on here with some dashboards. And then ultimately, at the end of the day, this is kind of the blow-up of the entire kind of very high-level wireframe of what a cloud deployment looks like with an open stack. This is actually going to be the General Mills example, where what's really going on here is each one of these is a platform in itself. So I don't know how many of you folks have contract manufacturers or people doing stuff on your behalf or multiple tiers of operation. But imagine a cloud technology here, like this is a co-op. In this example, this is what we call cow to cup. That's kind of a gross concept, but cow to cup, right? We make yogurt. The milk comes from the cow. What you eat is in the cup after we process it. You don't get it directly from the cow. That would be a bad thing. The co-ops and the farmers that have milk, they have a cloud and a semantic layer in this particular case right here, the processor, and then the plant operations. And the idea is that we're going to have, you can see this blue line here, cloud-to-cloud connectivity across our ecosystem. And in each section of the cloud, it's using a smart manufacturing wireframe. That's how that stuff's all connected together. So it scales n times. And so you take a look at some of your problems, and when you need to reach outside your own enterprise, how would you do that today? And we're happy to say that with the smart manufacturing concepts, you'll be able to do that. And so this is, at a very high level, what we're working on. This is a healthcare exam. I think I'm going to just go, yeah. So what I'm going to do with that, does anybody have any questions before we bring up the vendor panel? Yes, sir.
Yeah, there's a large number of test beds that are starting to be developed around the world.
Yep.
How does yours differentiate from one of the
I don't know if I can answer. I don't know all of the different.
When you think about your particular test bed, what are the ideal use cases for your test bed?
Well, how I would answer that would be smart manufacturing is about optimizing manufacturing. It's not about the transactions of the event. It's not about the plant floor discrete cells. I mean, a lot of stuff that Dean's doing in digital manufacturing will get cell-based. It'll be collaborative engineering. We're about optimizing manufacturing. So our unique, so a couple things, a couple really healthy problems that are really rich for us to solve is supply chain, going outside your own walls and trying to figure out how to do business with others, you know, suppliers and customers, and knitting that all together into a demand-driven. In Jesus's case, being able to take complicated problems and apply additional computing horsepower and modeling in a real-time ecosystem, that's also a very rich test case because it's not just a widget, it's not a discrete event of passing information. It is, I have to crunch it. I need some computing power that I didn't have before. I need to model my system. So a lot of these examples that are very rich are process industries versus discrete industries. I don't know if that answered.
No,
Okay. Yes?
It looks like on your one slide, the smart manufacturing, a major portion of that is the computational model and a section of that. But also what I see in other parts is that you're taking things like data into OSI software and you're reporting it out to Tableau. Is part of smart manufacturing also going to include apps that allow those companies' systems to talk together, to work together? Because that's a big problem.
Absolutely. Absolutely. So
How are those providers and those services and those softwares, are they getting on board?
well, we'll table that. We'll ask that question of these software providers when they come up here.
So on your last slide where you had them sharing,
Yes.
were they sharing more than data? Were they sharing the applications?
Yes. And then in that model, they are in control of what they share. So there's a governance question and a provenance question. So you think about it. So as an example, we need certain information from a supplier to be able to optimize the supply chain. They aren't going to want to give us some of the information because it's business. Right? They're not going to tell us their efficiency. They're not going to tell us their raw costs, all that kind of stuff. But we might want the quantities, volumes, and attributes of that ingredient so that I can design my manufacturing location to tune in the recipes for the ingredients. So what's a little bit unique about food is all of our materials are driven by Mother Nature. So if crop year changes and weather changes and so on, I have to change my manufacturing location and its parameters to adjust for these variabilities.
I was thinking about some of the applications such as Tableau and things. If you had centralized support of that so that some of the small farmers who might not have the
Absolutely. Right.
abilities or whatever, that would take that burden away from them.
Correct. And that's the whole point.
Okay.
That's the whole point, right? Because the big guys can figure out how to do that, and the small guys don't know how to.
Yeah, they're farmers. IT is not in their job description.
Correct.
They have other things to do better.
Correct. Okay. Any other questions? Oh,
I was wondering if you could comment on your exploration of different, we'll say, the compute networking storage platforms. You chose OpenStack and, very popular, lots of things going on with it. But there's others. I just wondered, how did you arrive at that conclusion? Or that seemed to be one that the group knew best, so let's go with it?
I'll take that one offline because that's a long answer. So I'll take that one offline.
Question for Praxair. You invest $1 million gas sensors into the big building. How did you convince your management to do so?
Oh, well, can you hear me? Oh, well, it's a very good question, right? I want to say that there is a kind of half answer. There is two answers that are complementary. The first one is, obviously, we got financing from the Department of Energy, okay? But the second one is with still Praxair. I mean, the total project for Praxair, including the DOE project, is $2.8 million. And of those, $1.1 million is from Praxair. The $1.1 million we convince our management with the value. So because even with the implementation that is going to give us the efficiency that we get in the plant is high enough to cover that cost.